Let me just talk about one example, one application of advection equation. From previous video, we are discussing about the implications of advection equation, what advection equation is, and what is the meaning of advection equation. On the left hand side, you see that I have written the same advection equation but for some particular application. On the right hand side, we see that Q is the concentration of some contaminant, and U bar is the velocity of speed of that contaminant. On the left hand side, we see W, which is a different quantity. Imagine that someone is speaking, and his or her voice reach to another person, for example, another person. That wave, that sound actually reaches from one source, from one point to another by sound waves. So whatever one person says, it can be heard from another member, another person. So that sound wave, since it is a wave, so it will be covered, or it can be a part of advection equation, or it can be display by mathematically display by the advection equation, since there is a transportation. So the left hand side, what you see over here, you see the C is speed of sound. And W, what is W? As you know that sound is actually a pressure wave, and the sound from one person, for example, move from one place to another by the air. There is an air. This is an air, and air has molecules. When someone speaks, or maybe you can hear some voice from somewhere, then that sound, or that pressure, in fact, that pressure collide with molecules, and that molecules transfer that pressure to another one, and so on. So it is a kind of interaction between molecules that generate that transfer pressure from one place to another. So it means that there is an advection of pressure. So it should be represented by the advection equation. So what we do, C actually represents this quantity W, and W can be the pressure. W is a combination of pressure and velocity. Combination of pressure and velocity. Since you have pressure, which is pressure wave, which is traveling from one place to another, and it is a wave as well, so it is represented by the advection equation. Such phenomena is called one-way wave motion. If the wave is traveling, I will show you the animation at the end. The wave is traveling from left to right. This is one-way wave motion. It can happen that the wave is traveling from right to left. This is also one-way wave motion. Okay. So this is an equation which is responsible for the travel of sound from one place to another. It has application in, for example, you sometime hear from the news that there is an acoustic chamber or acoustic house or acoustic room, for example. So when there is a sound, there is an acoustic. So what is acoustics? Acoustic is the sound propagation in underwater environment or maybe through atmosphere, like this phenomena where one person speaks and another person listen. Then this is acoustics. Then it also has application. One-way wave motion has application, not this one, but one-way wave motion, it has application in geophysics. In geophysics, you may listen from the news the seismic waves, like the earthquake waves. These are the waves which travel from one place to another. These are one-way wave motion. And some other thing as well, electromagnetics as well. These are radio waves that propagate from one place to another. So one-way wave motion has many applications. We will talk about that in the next video as well. So here, let me just show you in animation, which is written in MATLAB, and I will show you the animation now. So you can see how the traveling wave look like. And we will talk about that later on as well. For example, you can see that this is the traveling wave. You can see it is moving from left to right. On the y-axis, we have Q. On the x-axis, we have X. And this is another wave. And it is moving from left to right. So these are the waves actually. So this was all about the one-way wave motion and application of advection equation. Thank you for watching.